Okay, we are live. Hello, everyone, and welcome to the first session of my workshop series that I'm calling NextGen Geospatial. So this is a workshop series that's put on by the University of Arizona Data Lab, which is part of the Data Science Institute here at U of A. My name is Jeffrey Gillan, and I'm a research data scientist and I work at the Data Science Institute, and I also work for a group called Cybers. That's what you see here on my screen. Helping me in this workshop is my colleague, Carlos Lizarraga. He's a data science educator and also works for the Data Science Institute here at the University of Arizona. Okay, so let's talk about this workshop series. Let me share my screen. Okay, hopefully everyone can see it. So we are organizing everything on GitHub. And so all the course content, the schedule, everything we're doing is based out of GitHub. So the NextGen Geospatial Workshop Series is at this address here on GitHub. You don't have to have a user account to see the material, but it also, always helps. So what is this workshop? So this is a weekly 1-hour workshop series where we're going to cover a variety of geospatial topics. So with this lesson and most of the ones to follow, we will start with a little bit of theory and then end up doing hands-on exercises. Oftentimes we might be using Jupyter notebooks or have some other kind of coding environment. The idea is with this workshop is that we're going to step out of conventional GIS frameworks. So we're not going to be doing a lot of pointing and clicking within graphical user interfaces. We're going to focus more on kind of data science aspects of geospatial. We're going to be showing you some essential Python libraries. We'll talk about and introduce you to cloud native formats. Throughout this course, we're going to be using and showing you how to harness cloud computing platforms. There's several of them that we're going to use. We're going to get into doing a few different drone imagery analysis things later on in the semester. And then we'll finish with showing you how to build geospatial analysis pipelines. So every lesson is designed to be kind of its own discrete thing. You don't have to attend, this is not an ongoing building up of knowledge. So you can come in, you can pop out. And hopefully at the end of just, this 1 hour, you learn about a new tool. And so then you can go away, explore deeper yourself and try to apply it to your own work. All right, so you've already learned about myself and Carlos. Let's just go ahead and go to our first lesson today, which is called Geospatial Data APIs. All right. Geospatial Data APIs. So for this inaugural session, we're going to learn about APIs. We're going to talk about what they are, why you'd want to use one. And then the last half of class, we're going to do a hands-on example using satellite imagery from the satellite imagery company Planet. So we will be doing Python scripting in a Jupyter notebook and hosting it on Google Colab. And we will explain all of what that means, as we go along. And so we're going to be working with Planet imagery. Okay, so before we get started, a prerequisite we need to have a login to Planet. Planet.com. And if you could find the login button, we can get ourselves signed in. Before we do that, let's just talk about Planet a little bit. So at the University of Arizona, there is an institute called the Institute for Computation and Data Enabled Insight, or ICDI. And they have been gracious enough to purchase this fantastic campus-wide license. So all U of A personnel, from students, staff, faculty, they can all access, download, use all kinds of satellite data imagery products for free. So if you want to learn more about that, you can click right here. It takes you to, it takes you to where ICDI has a bit more information. And this is where you can do a student sign up or a researcher sign up. So if you haven't already and you're interested in getting free satellite imagery from Planet, please check out these links. Okay, so back to Planet. We need to get ourselves logged in. I got my password here. Did I do it wrong? Let's drag it. Okay, that time it worked. Okay, when I log in, I come to my user dashboard. And we're in here today because we need to find an API key. So if I go into my settings, it's written right here. I can see it. I can copy it. So let's just keep this web page up, on a different tab. And we'll come back to it later when we actually need to use the API key when we're analyzing satellite imagery. Okay, now that we've done that, let's go back to the lesson. Okay, we found our API key. Okay, so let's get started with the actual content. So geospatial data is everywhere online. It's the year 2024, and man, I can find GIS data, remotely sensed data, all kinds, all varieties, almost anything that can be, put into a mapping form and have coordinates is available online to find, and most of it is free, from satellite imagery, drone imagery, airplane imagery, stream networks, road networks, the location of millions of trees, fire polygons, wildlife habitat, human population census tracts. I mean, it's just, there's no end to the amount of GIS data that we can find online. We're not going to spend much time talking about where to find them. You can do some Googling. There's just tons and tons and tons. When it comes to Earth observation and satellites that orbit the Earth and take pictures, there's around 1,600 satellites orbiting the Earth, snapping pictures around the clock in a variety of different frequencies and bands. Specifically today, we're going to focus and use Planet satellite imagery. So Planet is a company. They operate more than 200 satellites, and these satellites are orbiting, and they are covering almost the entire Earth landmass every single day. So their flagship imagery product is called Planet Scope, and it's 4 bands: red, green, blue, and near infrared, and has a 3-meter spatial resolution. So that is, a big chunk of the data you can get from Planet, and it's available like almost every day. And so I could look for data and I could find it. They probably have imagery for, January 16th, January 17th, January 19th, January 20, 21st. Almost every day they've got some kind of imagery of almost anywhere on Earth. It's quite amazing. So here we have an image from Planet, and besides just the raw imagery, they also make imagery products. Like they do some analysis and do some interpretation to identify what we're actually seeing. So this is a above ground forest carbon image that Planet is making available, and I do believe this is available through the University of Arizona campus license. Here's just a graphic showing you public satellites. So, NASA has launched and operates lots of satellites. There is no lack of data when it comes to satellite data, GIS data that we can analyze. There's just so much out there, guys. All right, data delivery. The typical way, we'll start with that. So the vast majority of online geospatial data is downloaded through a graphical user interface, like a graphical website. Yeah, for good reason too. You know why? Because it's just easy. It's so easy to do. So let's give me a quick little example here. Not log out. What do I want to do here? Okay, if I go to Plant Explore, this will open up their graphical user interface to search for data, right? So this is what most GIS or remotely sensed data searches look like. A lot of times the good ones have a map. We can zoom into Arizona. We can make a bounding box, for instance, or let's make a circle. Circle kind of near Tucson. Excellent. And then I can do some dates. Let's see, December 1st to January 10th. So just this last month. Okay, so we have all kinds of imagery that's already available, and it was just collected not very long ago, just this last month. That's January 10th. Okay, so you guys get the idea that most GIS and remotely sensed data, a lot of it is searchable and findable and downloadable via a website, some nice graphical website with a map interface, and then being able to do some kind of filtering. Fantastic. Okay, so that's a typical way. Nothing wrong with it. I did it for years and years, and for most researchers, this is still the best way to do it. If you just need a few satellite scenes for your project, your research study area, you're not going to be able to really beat this method. The typical way is usually the best way. However, if you want to do things the data science way, you might be in a little select group that wants to make things a little harder for yourself. But with great challenge comes great reward, comes great power. And so you can actually search for and download imagery through Planet and a lot of other data sources through scripting languages. The reason we're doing this because it allows you to automate repetitive tasks and scale your imagery analysis well beyond what is possible with point and click computing. So the way to access and get data programmatically or through a scripting language, we're probably going to be using something called an API or an application programming interface. Okay, let's define an API. An API, in very simple terms, is a set of protocols for communicating between computers over the web. So it's just like a website, but specifically for transferring data. So just like a website, an API is served on a computer somewhere, and that API has a specific web address, or just like a website. But instead of interacting with the web address through a graphical browser, you interact with that API through scripting languages. And so APIs and websites are really similar. They both use HTTP. For the hands-on example today, and through Planet, we're going to be using something that's called a REST API, which stands for Representational State Transfer. It's a common API architecture. It's easy for scaling, integration. You don't need to know those things exactly, but it's kind of a standard architecture that is often used for data transfer. Another thing that's typically used in a REST API is the the format JSON, which is JavaScript object notation. JSON is just a file format, and it's really great for writing descriptions of data, like metadata. It's machine readable, it's human readable. So JSON is typically a part of REST APIs. What else? So REST APIs often have like a common terminology between them. Makes it easy to go from one to the other. They often have commands for requests. So request is me, the user, the client, trying to get information from the API. And there's often standard responses, which is the API sending information back to me, the user or the client. Some examples of requests that we will use in the hands-on exercise is the GET request, okay, and then the POST request. And so we'll see examples of both of those in our Python examples. All right, the most important, why use APIs to get data when using a web browser or going through the GUI is just so much easier? And the answer is, for most people, please stick with the web browser. It is easy to do. There's nothing broken here. just use the tools that are available to you. However, if you want to be a more powerful data science wizard, and you need something to be much bigger, then you can go into scripting languages and APIs. So here are the top reasons to use the APIs. The first is automation and scalability. If I need to download and analyze hundreds or thousands of images, this could be a really good case study of why I might want to use APIs and scripting languages. For instance, maybe you're monitoring deforestation, or maybe you're looking at crop production, and you're doing this in a time series, you're doing this over a huge area, then maybe APIs are for you. So it's about doing things on big scales. If you are just looking at forest deforestation of a small little area, one point in time, it's probably best to just get the data through web browsing. Okay, and the second reason why you might want to use APIs is because of reproducibility and the sharing of research. So here at the Data Science Institute and Cybers, we're very much proponents of open science. And open science is all about taking anything that you have done, and that could be you generated data, or you created code, or you made something, make that something available to everyone else. Just put it online for free so other people can take it and build on it. And so that's what we mean by reproducibility and sharing of research. So by using APIs and getting data in a programmatic way, it becomes a script, right? And that script can be just directly run by anyone else. And so it makes transferring your knowledge of what you did to someone with extreme ease. Okay, and the other reasons, handling large data sets, real-time data processing, those could be other reasons why you use a data API. Okay, so let's get to our hands-on exercise. Like we mentioned before, we are going to be tapping into an API from the satellite imagery company Planet. We will be using a Python scripting language, and doing so in a Google Colab Jupyter notebook. Before we get there, let me define a few things for you guys. Let's do some vocab here. Okay, Jupyter Notebook is the first thing. So what is a Jupyter Notebook? It's a browser-based environment. Let me highlight it so you know where I'm looking. It's a browser-based environment for writing computer code in Python, R, or Julia. So the notebook can be served on your local machine or on a remote machine that you tap into through the internet. And so notebooks are just really nice tools for sharing and collaborating on code. And they are perfect for a classroom of students all doing code together, which we are doing. So we're using a Jupyter notebook. And specifically, we're going to be hosting a Jupyter Notebook on Google Colab. So Google Colab is a computer. It's a virtual machine that Google has created. And if we have a Google account, which we all do, then we can just log in and we can use their free tier. It gives us a little computer that has, a small allocation of RAM. It actually has several terabytes of disk storage and computing power in terms of CPU. So this is just a great little environment, but it's temporary. Okay, so we're going to use it today to do our code, to code along together. But by tomorrow, that virtual machine and that project you work on is going to vanish forever. So Colab is not a place to store your data. It is a good place to just work temporarily. Okay, it can also be nice to work in the cloud because I don't have to deal with trying to install specific software, specific libraries on my machine. With Google Colab, we just have this kind of fresh new installation where it can be easy to get started. Okay, so that's a kind of a quick definition of what Google Colab is. Let's just go ahead and launch. So we go to our button here, open in Colab. Okay, so hopefully you see this this similar screen to what I have here. So here we are in Google Colab. First thing I want to do is connect. I can just type or click connect here. And so it's going to hook me up with some computing resources. Okay. Looks like I have some RAM. I have some disk space, which is great. And I have a Python kernel. So here I am in a notebook and I can run code and I can get immediate results right here in the notebook. Okay, so let's just kind of go through this line by line here. Because this workshop session is only an hour long, we don't have time to really get into all the weeds of all the Python code that I have written. I will go through and explain kind of what each of them is doing, but I'm not going to explain line by line. We're not going to learn Python really together through these workshops. That would be great if you probably did it on your own time. You can watch this video repeatedly, look through the code yourself to kind of figure out what's going on. For the most part, I will explain kind of just what the boxes do and how the workflow works. Okay, so let's get started. Our first line of code here is the things I like to do when I start in a Colab or try to figure out what my computing environment is. I like to first determine what the Python version we are working in is. And so I have a couple lines of code that will do that. Yep, this notebook was not authored by Google. It was authored by Jeff Gillan. Let's run anyway. Okay, so we're using Python 3.10.12. Excellent. Okay, and Colab comes with many Python libraries that are pre-installed. And if you're interested to see the list of all these installed packages, you can type this !pip freeze. Okay, if we do that, then it's going to list every single Python library that is installed in our environment. And I like to look at this sometimes. I'm just curious what they have in here, what they don't have in here. And then versions are really important. A lot of times code will not work because you have the wrong version and it's incompatible with a version of some other dependent software. So that's just kind of a good software etiquette. I just want to look at what our environment is and what software we have. Whoa, connecting. Okay, I must have disconnected for a second. Okay, I guess I'm back. All right, next step in this is let's import the libraries that we're going to use to tap into the Planet API. So the libraries have already been installed. They are installed stock in this Google Colab session. So let's just hit run. Okay, they're in. They are now in our environment, and we can pull tools out of them and use them. The next line of code is something called a helper function. It's just all about helping to print JSON format in a way that's easy for the eye to read. That's all it is. Okay, that's done. Okay, next one is very important. So this is where we set the variable for our API key. And let's go back to our user account here. We go back to my settings. There's my API key. I hit copy. Okay. I go back in here and I will paste it. So the API key kind of works like a password. As we tap into the Planet API, it needs to verify or authenticate who I am. And I do that through an API key, which is just a string of letters and numbers. I'll paste it. So everyone should find their API key and paste in theirs. Okay, next. So next up is we need to define the addresses. What's the address of the APIs that we're tapping into? Remember, it's just a URL, just like google.com or whatever. Only it's instead of going to a graphical website, we're going to a data API. And so Planet has a few different API addresses that we can go to. Here is one here. And each of them kind of do different things. Okay, I guess we didn't define the term API endpoint yet. An API endpoint is just a specific address. And specific API addresses or endpoints can have specific behaviors. And so for us to do our lesson today, we have to tap into 3 different addresses that Planet has provided. One is where we can get the statistics of our search. Another one is where we actually do our filtering and our searching, and we can download one image at a time. And this other one is an orders URL, and that's where we can automate it and do big orders. Okay, next up. So let's get into the mechanics of actually searching and downloading imagery using the Planet Data API. First thing is a geographic filter. So we want to specify where in geographic space we are interested in getting satellite imagery. We can do so at geojson.com. I go to that website right there. No. This is a website where you can just create a GeoJSON just by drawing it. Okay, boom, I drew it, and this is the JSON. So I can take that information and then copy and paste it into my box here, into my code snippet. And so that's the geographic filter. Okay. Next, let's define some more filters. So besides geometry, okay, we've done geometry. Next, we're interested in doing a search regarding a date range. Okay, this is where you specify, I would like the imagery from this date to this date. Okay, and this is where we actually type it in, is right here. GTE stands for greater than or equals, and LTE stands for less than or equals. And so when I want to do a date range filter, I type in, the first date. And so I put in June 18th, 2020 as like the time to start, and then June 19th 2020 as the time to end my date filtering. So basically just one day. I'm just looking for imagery on that one day, June 18th, 2020. We'll find out in a little bit why we're doing that. Okay, what other kind of filters can you do? You can also do clouds. You can be like, hey, I only want to see images that have certain amount of clouds, because if it's really cloudy, then I don't want that imagery. So that's a cloud cover filter you can create. And in ours, we did show me only images that have less than or equal to 50% cloud cover. Okay, so I have the geography, I have the date range, and the cloud filter. And I can put and combine those three filters together into a single filter. And so that filter is called combine filter. Okay, so that it's now a variable called combine filter, which includes those three things. All right, I got my filters ready. Now we're going to send the filtered request to the Planet API. And it's going to tell us how many imagery assets or imagery items are available based on our filter. Okay. Whoops, I probably have to run these, don't I? I already have a pre-made geo filter, so I'm going to run that. Okay, back to sending the filtered request to the Planet API. I have to create an API request object, which I'm doing right here, which includes the combined filter. Okay. And then I'm going to do what's called a post request. We talked about that earlier. I'm going to send that that filtered request, and it's going to send something back to me. So we're doing this as a post request, as you can see right here. And once I do that, it should print out the results in a JSON type format. Okay, cool. So we sent it to the Planet API. It responded and said that within your filter, there is 16 items that are available. Great. So next, I would like to do a filtered request, but I don't want just the number of items. Like, tell me what the imagery IDs are. Tell me like what is actually there. Okay, let's do that. Create our object again. It's the same thing that we did previously. Send a post request again, only the address is a little different. Instead of sending it to the statistics address, we're sending it to the quick search endpoint address. Okay, and then all goes well, the API will respond with the names or IDs of the imagery items. Okay, geographic coordinates. This is what it's responding. So it's saying that as this ID here, and then here's all the parameters or all the descriptors of that imagery product. Cool. Okay, yeah, I'm just looking at the first one. So if there's 16, I don't want to look at all 16. I just want to look at one. And that's what it's showing me here. Okay, next up is we need to create a variable that just has the image IDs only. Click that. Okay, and so this should be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. There's 16 items, and I now know what all of those item IDs are. Okay, next is which images do you want to download? And I've already predetermined this. I've already looked through the imagery and determined that this ID here is interesting to me. And so I would like to get it. So I'm going to send a GET request to the Planet API saying, hey, I am interested in this image ID right here. Let's do it. Okay, and when I do that, it then lists all the assets that are associated with that item. So the term item and asset are actually two very distinct things. An item is a specific collection event, like the planet scope imagery on January 18th at 2 p.m. The assets are all the different imagery products that can be made from that single collection. It could be digital numbers, raw digital numbers, satellite imagery. It could be radiance. It could be surface reflectance. There's different processing products that can be made, and those are called assets. So this last block of code then tells me all the different assets that are available for that item. Okay. Next is, when it comes to planet imagery, it is in cloud storage. And if that asset or that item has not been touched or accessed in 30 days, it goes into something called cold storage. So it's not activated. And if we want to get it, we need to activate it. So let's just check. Is it active? It is active, right? Okay, that's because I did this the other day. If this was a new search and no one had actually gotten that imagery recently, it would be inactive. All right, and then the next one is we're going to send a request to have the imagery activated if it is not active. Great. Next up is let's check the status of that activation. It is active, of course. If it was not active, it would take maybe a few minutes, maybe 10 or 15 minutes for it to go from inactive to active. Okay, it's active. I know exactly what I want. So I would like to now get that specific, I'd like to get that specific asset and give me the download link for it. So if I click on this link right here, it's now going to download it to my computer. And I kind of want to stop it because that's a really big satellite imagery file. Oh, I can't stop it. Oh well, I'll also have to delete that later. Okay, next up is, let's say you want to keep processing or keep analyzing your imagery in Google Colab. Instead of downloading it to my local computer, why don't I just download it directly into Colab? Okay, so let's do that. Okay, it said image downloaded successfully. Cool. So to check, we can open this this folder looking thing right here. And we have it. It's called Bighorn Fire. It's called Bighorn Fire because I called it bighornfire.tiff. Okay, so it is now here. It's in our environment, and so now we can play with it. All right, so quickly, let's just look at it. Let's look at the satellite imagery to see what we have. To do so, we're going to install a few libraries. One is called raster.io, another is called GDAL. And then we'll bring those libraries into our computing environment. Okay, still going. Okay, they've been installed and imported into our environment. Next, I'm just going to set a variable for the path of this thing, the Bighorn Fire. Let's hit image path. Okay, I found that anytime you fire up a Google Colab, your data, the stuff that you bring in, is going to be here. It's going to be at /content/whatever your file is. So content is where your stuff is going to be. Okay, the next one is going to visualize. We're going to see a picture of the satellite imagery that we have downloaded. So this isn't useful to be aware of, that planet scope imagery, the band order, band 1 is blue, band 2 is green, band 3 is red, band 4 is near infrared. Right, and we wanted to display as a false color composite, which means that we're showing near infrared light as red. We're showing red light as green, and we're showing green light as blue. All right, and that's what it looks like. Oh, this image was taken from June 18th, 2020, when the Bighorn Fire was burning the Santa Catalina Mountains just north of Tucson here. And we can make that any color we want. But we'll have other lessons for visualizing. So yeah, here's a satellite image that we downloaded. All right, so that was just a super quick tutorial on how to do a filtered search, and download a single imagery asset. Now, if you want to scale things up, and I know you do, if you want to download dozens, hundreds of satellite images and bring them in to your computing environment in an automated way, you can use the Planet Orders API, which is just a different address that Planet has. So let's do that real quick. So as an easy example, I'm interested in these 3 imagery products. Okay. So I am making I'm defining the IDs, the item IDs, and the type of asset that I want to download. I am downloading something called the analytic UDM2 asset type. Okay, I made that into a variable. Okay, then I do my API request. Well, that's not yet. I create an API request object, which lists the products I want. And I'm just going to give it a random name. I'm going to call it Mount Lemon. And I want it to be delivered as a zip. Okay. I have to run these things, don't I? Okay, and by typing order request, it should just spit out, what I just created. So this is the object, API request object that I just created. That's what I am going to then request. Okay. So now I send the post request to the orders API. You can see the request.post. So that's what I'm going to send. I'm like, okay, these are the things I need. Okay, and it gives me a response, and I'm printing that response in a GeoJSON format. And so I send out my order, and now it is queued. Okay, that's nice. Let's go back to my user account in Planet and look at my orders. Okay, and you can see it running. So I have made a request for an order, and it's in the middle of processing. I've already done this 4 other times because I was working on this lesson. But this will take, I mean, I guess it depends on how big your order is, but for this small order of 3 images, it doesn't take very long, maybe 15 minutes or something. But let's just go ahead and skip ahead and say that our order is already complete. Okay, so next we can do is we can check if your order is ready for download. And so to check, we take the orders API URL, which is this thing here, api.planet.com/compute/ops/orders/v2. And then we add in our specific order ID. Okay. And what is the order ID that we want? I can probably get it from a previous order. Here's one. Okay, I'm going to copy and paste that. I'm going to put that right in here. Okay. So this whole chunk of code is going to check if my order is ready for download. Let's see. Okay, order is ready. So if it were not ready, it would say it was like still in the processing phase here. Let's test that. Let's go to this order. Order is still processing. Okay, it works. All right, now we have to go back to it. Okay, order is ready. Okay, and so order is ready and it's listing all the different orders, all the different files that I am downloading. Excellent, that's a lot. All right, and this chunk of code is going to download that order into Colab, and then we can play with it. All right, let's take a little bit of time. So it should go into our content folder. Yep, here it is. All of these files are brand new. These are the ones that I just downloaded. Okay, so that comes to the end of the tutorial. So in this lesson, we learned about how to tap into the Planet API using a unique API key. We did API requests to get statistics on how many images were in this specific filter or filtered search. Then we found one of interest. We downloaded it to our local computer, and we also downloaded it into Colab. And then finally, we used the orders API to do a bulk download. For our example, we used 3, but I think you could do up to like 500. You can really scale this up. So geospatial data APIs are about scaling up and automation and doing things on really big scales. So I hope this tutorial and this lesson has been useful to you to help you with your geospatial data science. I'm going to stop my share. And so that is the end of today's lesson for the inaugural session of NextGen Geospatial. And we'll see you next week. And what are we going to talk about next week? I lost it. Okay, next week, Carlos Lizarraga, my colleague, is going to be leading a session on using Python data formats. So specifically go into different libraries you can use for analyzing and visualizing raster and vector data. So thank you very much, and we'll see you next time.